All right, so we're going to start off looking at section 2.2, well, second part of section 2.2, which is on finding complete graphs. So we're going to start with a word problem right away about a company that has two kinds of costs. They have fixed costs, and then they also have variable costs. So if you were running a business, an example of a fixed cost, or to kind of relate it to the school, fixed cost would be like the salaries, right? People that make a salary, it's the same all year long, so they already know what the costs are going to be for the salary. But variable cost would be things maybe like supplies and materials. So like if they had to buy paper for the photocopier, that's a variable. Depends how much paper is used. If they have to buy pipe for plumbing, depends on how much pipe is used. Right? So those are variable costs. They change depending on the use. So this particular company has a fixed cost of $200,000. And they have a variable cost of making, they print t-shirts. So they make t-shirts. And it costs them $1.50 for every shirt that they make. And then they sell the shirt for $4. Okay, so three different terms are going to come up as we go through this problem. There's cost, there's revenue, and then there's profit. Okay? Cost is any money that the company spends. Right? Revenue is any money that the company takes in. Just because a company sells a shirt for $4, it doesn't necessarily mean it's profit, right? Because they had to spend $200,000 in fixed costs. So we don't know if that $4 is profit. Profit is the difference between the two. If you take your revenue and you subtract your costs, that'll tell you how much money you made. So revenue could definitely be a negative number, right? If you didn't make back enough money to cover your costs, then your business is going to lose money. So what we're going to do first is write down two equations, one that represents the costs, and then one that represents the revenue. And after we come up with the two equations, then we'll graph them, make sure we find a complete window, and we'll keep in mind what would make sense for the variable. We're selling t-shirts, so it might not make sense to include negatives, decimals, things like that. Okay, so let's start with our costs. So we have to write the cost as a function of how many shirts we sell. Okay, so we should pick a letter. What letter do we normally use to represent the independent variable? What is it? X, yeah. So let's use X. And X will be the number of shirts we sell. And to make it simple, we're going to assume that however many shirts we make is the same number of shirts we sell. So if we make 50 shirts, we sell 50 shirts. So this is a company that only produces what they need because they already have an order for it and it's already sold. Okay. So they kind of make it on demand. All right, so let's start with our costs. How would we represent the variable costs depending on the number of shirts we make? How would we get the total for that? Yep.
You do like 1.5 times X.
Yep, so there's your variable costs. 1.5 times X. But those aren't the company's only costs. What else do we have to put there to get the total costs? Variable and fixed. Yep.
We would need to put the 200,000.
And how would you put that?
Would it be subtracting the 200,000?
So if you wanted to find the total between two different costs, would you subtract the two to find the total?
No, you would add.
Yeah, you would add. So we have to add the amount of money they spend to print the shirts plus the amount of money that they spend on the fixed costs. Okay, the fixed costs could be like salaries of employees, or maybe the cost to rent the building, whatever that is. Okay, so there's the formula for the costs. Okay, now, how about the formula for the revenue? So the revenue, like if they were selling shirts at a store, it's the formula you would use to figure out how much money is in the cash register if you knew how many shirts you sold. Yeah?
4x.
4x. Yeah. So there's the formula for the cost and the revenue. Any questions how we got those two formulas? So now we're going to graph it. On our calculator. Okay, so we've typed in our two equations. What do we have to do before we go to graph? We always have to do this, yeah?
Set the window.
Yeah, we got to set the window. So remember, X is the number of shirts that we sell. What's the lowest number of shirts we could sell? 0. We can't go lower than 0. The maximum amount of shirts, well, we don't know. There is no limit on how many shirts we sell. Let's say we sell up to 1,000 shirts. Okay. And Y, depending on which equation you look at, is either your cost or your revenue. Let's look at the revenue. What's the smallest amount of revenue you could make? 0. If you don't sell any shirts, you're not going to make any money. And Y max, well, I got a y-intercept at 200,000, so I need to go to at least that. I'm going to go to 250. Okay, so here's my two graphs.
Pretty good.
Do those look good?
I didn't even know the second one.
Zoom out a little bit.
So yeah, we got to zoom out more. We've got to look further to the right. Okay, so right now we're only selling 1,000 shirts. Let's go to like 30,000 shirts. All right, now I can start to see my costs, and I can see my revenue. And what's happening? Yeah? They're getting closer, right? Because I sell the shirt for more than it costs to make it. So my revenue is catching up to my costs. So we got to look further to the right, and then it's also probably going to be a little bit higher. So let's set this up to, let's try 400,000. And let's say we sell 100,000 shirts. Okay, so there's my costs. And here's my revenue. Okay, so that's a good picture. Okay, that first picture we had where they basically looked like two horizontal lines, we couldn't even tell that they were going up because the slope goes up very slowly. Okay, the bottom one does go up quicker, but it still takes a while. Okay, so here's our, oops. There's our graph and the window that we used. Make sure we put that too. It's right there. I think I grabbed the window before it finished writing all the numbers on it, but that's okay. We don't need that last one. So just the mins and the maxes. Any question on the two equations or how we got our window? All right, now this point, that is something special. Anybody know what's happening right there? Yeah?
You break even.
Right, that's called the break-even point. Right, so that's the point where the cost and the revenue are the same. However much money you had to invest in your business, you've now recovered all that money, and if you continue to sell your product, you're going to start making money. So we already kind of pointed that out. If you're looking at a graph of cost and revenue, where is the break-even point? It's where, what happens, yeah?
The two lines intersect.
Right, it's where the two lines intersect. So for a graph of cost and revenue, where is this point? It's where the lines intersect. It's where the lines intersect. All right, so now we're going to look at our problem and we're going to find the break-even point. Yep.
Oh, I was just gonna ask, for example 1, if that was on a test, for the answer, would you just be looking for the graph? Or-
So it says find complete graphs of the algebraic representation. So first I'd be looking for the equations, and then I'd be looking for the window that you use to get that picture. So the equations and the window.
Oh, thank you.
All right, so let's figure out the number of shirts that the company in that example has to sell to break even. And we're going to do it two different ways. The first way we'll do it is algebraically, and the second way we'll do it on the calculator. All right, so what is the definition again of break-even point? It's where,
The two lines intersect.
and how would you write it as using the word equals in there? It's where, right, it's where the cost and the revenue are equal. It's where cost equals revenue. So to solve it algebraically, we just have to go look up the two formulas that we figured out and then fill them in where we have cost and revenue. Okay, so our costs is 1.5x plus 200,000. And the revenue is 4x. What would be our first step to get x by itself? What is it?
Divide by 4.
Divide by 4. I mean, you could, but that's not going to help us to get x by itself because we're still going to have x's on both sides. Yep.
Subtract by 1.5.
Yeah, I would subtract the 1.5x. And now we don't have to deal with x's in two different spots. So that's gone. We get 200,000 equals 2.5x. And what would be our last step to get x by itself?
Divide by 2.5.
Yep, I'm going to divide by 2.5. Divide by 2.5. And that's going to come out to 80,000. And that's shirts. Okay, that's 80,000 shirts. And that's what they wanted to know. How many shirts do you have to sell to break even? Okay. Now let's look at the same problem, but this time we'll do it on the calculator. The calculator can automatically figure out where those two lines cross. Okay, have we done that before? No?
Just
I think so.
find where two lines cross.
Yeah.
Yeah.
How do we do it? What do you have to press?
What was it? Was it calc?
Second. Calc. Yep.
Intersect.
And then intersect.
Yeah.
Yep. Option 5. Because there are only 2 lines on the screen and they only cross in one spot, you basically can just hit enter 3 times. Pick a point on the blue, pick a point on the red, pick a point anywhere, and it tells you where they cross.
What did we pick?
Second calc.
Second calc and then intersect.
Second trade, second.
So it shows us that the intersection point is when x is 80,000, which is exactly what we got when we solved it algebraically. So I guess I'll put this over on the graphical side.
So can we either do it one of 2 ways on the test?
In this problem you could, yep. Yep, it doesn't say how to do it, so you could do it either way.
Are there problems that it's only possible using one way, or is it always going to be possible using both?
It depends on how difficult this equation is to solve. So if this equation became much more complicated than it is here, it might be one that we don't know how to solve algebraically. So we would have to do it graphically. The only downside to graphically is it will always give you a decimal, all right, or an integer. If I wanted an exact answer, that's where you might have to do it algebraically. Algebraically, you can always get the exact answer. But in this case, because it doesn't come out to a decimal, the graphing calculator will give it to you exact as well. But we were lucky.
Do we have to record what difference here?
This one doesn't say to do that. It just says how many shirts do they have to sell.
Okay.
So, nope. Yep, just 80,000. So now, what would be the cost for the company if they make 80,000 shirts? Yeah? $320,000. What would be the revenue for the company if they make 80,000 shirts? Yeah? 320,000. The cost and the revenue are exactly the same. What would be the profit? So at this point, it cost them $320,000 to make the shirts, and they took in a revenue of $320,000. So what would their profit be?
240,000.
They spent exactly as much as they took in. They spent $320,000. They made $320,000. Right. The revenue in this case is 0. They didn't actually make any money yet. This is the break-even point. Now, if they continue to sell shirts, now the red line is above. They're going to be making money. Yes. Yeah. Any questions on that one? That's all that was left in 2.2. So we're done with 2.2. Okay, so last thing we're going to look at is 2.3. Solving equations. In order for something, we're going to look at 2 kinds of equations, linear and quadratic, just those 2. In order for something to be an equation, what does it have to have?
An equal sign.
Right, it's got to have an equal sign. Right? It has to have an equality symbol between 2 expressions. And if the particular variable in your equation is x, then you can say that you have an equation in x. In x just means the equation I wrote uses the letter x. So 2 expressions. Well, that's an expression. In particular, that's an algebraic expression. That's an expression. That one on the right is numeric. Put an equal sign between them. Now you have an equation. So it's an equal sign between 2 expressions. And this one is an equation in x. Uses the letter x. Okay. To solve an equation means to find the values that make it true. When you're solving a linear equation, it generally has, well, how about this one? How many solutions would this have? It only has one. Okay, and that's the standard case. When you're solving linear, it has one. Quadratic has two. Now there are some special equations. I said usually linear has one solution, but it is possible that we have an equation that's called an identity. With an identity, it is true all of the time. There's an infinite amount of solutions. So how could you get an identity? Well, let's look at this equation. 3x plus 2 equals 3 times x plus 1 in parentheses minus 1. What would be your first step on the right-hand side? Dylan? Yeah, and when you distribute that out, what's that going to give you? Yep, it's going to give you 3x plus 3, but then you have a minus 1. So it's going to give you 3x plus 2. Now, if you wanted to put all the x's on the same side, you could subtract them. But then you end up with 2, because that's gone, equals 2. You end up with 2 equals 2. That's an identity. When all the letters cancel out and you're left with a true statement, you're done. And it means that x can be anything. No matter what you plug in for x, it will always work because the left side and the right side are identical. They look a little different, but they're really not. Okay, so that's a special case. The more typical case is like the one I had right here. This is called a conditional equation. There's a condition that will make it true if you pick the right number for x. In the example I had up above, it would be 5. And I wrote the same one right there. So a conditional equation is true for certain values of x. Most, if not all, of the equations that we solve today are going to be conditional. All right, so what they might have you do on some problems is check your solution or verify. Okay? If they ask you to verify a number as a solution, you just take the number that they give you and you substitute it back in. And you see if you get a true signal. Okay, so that's going to be the first one we do. It's going to be a verify. So they want us to verify that -2 is a solution. Okay. How would I verify that -2 is a solution? What would I do? Yep, sure. Yeah, plug in -2. Everywhere you have an x, and see if you get a true statement. So let's do it out. What's -2 cubed? -8 minus -2 becomes what? That becomes a +2. And what's -8 plus 2? -6. Plus 6, 0. So does that mean -2 is or is not a solution?
It is.
It is, yes. So -2 is a solution, and we verified it. Okay, so that's what verify means. Now that's a cubic. Okay? So we're not going to talk about solving cubics today. I might give you a number and ask you to verify, but I wouldn't ask you to figure out that number yourself. With a linear equation, I would. So a linear equation is anything that has the form ax plus b equals 0. This is a linear equation. Now this is also a linear equation. And you might say, well, yeah, but that doesn't look like the one above, right over here. But it could look that way. So a linear equation is anything that has this form or could be written in that form. Okay? I could bring the 8x to the other side. And now it's ax plus b equals 0. Any question on how I got from that to that?
Did you mean to subtract?
Just subtracted 8x
Oh,
from both sides. Okay, so anything that can be written with an x and it has to be to the first power. So if something's linear, can't have an x squared. You can't have an x in the bottom of a fraction. That doesn't count. You can't have a square root of x. If you had any of those things in your problem, it would make it non-linear. Okay, so only an x to the first power is allowed. And then you can have a constant. Plus, or it could be a minus. It could be a plus or a minus. Okay, so let's see if we can solve this equation. Okay, what property would I have to use on the left-hand side? I'm going to have to use it twice. Yep.
Distributive.
Yep. So we're going to distribute this out. So we get 4x minus 6 and 3x plus 3. Okay, so that's our first step. Distribute it out. Now, what can we do on the left-hand side? Now, we've got some like terms. We've got some x's, so we can combine those. And we've got some constants. Negative 6 plus 3 gives me how much? Negative 3. Okay, so that's starting to look a little simpler. What would we do next? Yeah?
Subtract 5x.
Yep. I would subtract the 5x from both sides. That's going to put all the x's on the left side. And now we've got 2x minus 3 equals 2. And if I wanted to, this wouldn't help me to get x alone, but I could put the 2 on the left side, and it would say 2x minus 5 equals 0. That's exactly the format of a linear equation. 2x minus 5 equals 0. So this was a linear equation, even though it didn't look like it at first. When you do it out, it is. All right, so we don't want to put everything on one side and get it equal to 0. We want to get x alone. So what's our second to last step? Christian, to get x by itself.
We could add 3.
Yep. Add 3 to both sides. It's going to give you 2x equals 5. And Nick, my last step.
You divide by 2.
Yep. Divide by 2. And there you go. So x equals 5 over 2. Okay, so any question on solving a linear equation? We've got a couple more we're going to solve relating to absolute value and then a mixture problem. So let's look at this one. When we solve absolute value equations, the ones I give you, they are always going to break down into two linear equations. What's the symbol for absolute value? You remember? Yeah.
They're like bars.
Yeah, the two vertical bars, two vertical lines. Yep. So I say that the first step is to split it into two equations after the absolute value is isolated. Okay, so what do I mean by isolated? This is an absolute value. That is isolated. There's nothing else on the outside of the absolute value bars on the left side. Here's an example. Of an absolute value that is not isolated. You have a +3. First step to solving this is to put the 3 on the other side. And how would you move the 3 over to the right? Yeah.
Subtract.
Yeah, you would subtract 3. Just like this. Okay, I'm not going to finish solving this one. But that would be your first step. Now you're ready to split it into two equations. Okay, but that's step one. Make sure the absolute value is isolated. Then we split it. The reason we're splitting it is to get rid of the absolute value bars. When you split it, the first equation that you write down is exactly the same as the original. You just take out the bars. That's it. Just write the same equation without the bars. The second equation, you start out the same way. It's the same as the original without the bars, but you make the number on the other side the opposite. That's what negate means. Make it the opposite. So first equation, same as the original without the bars. Second equation, same as the original without the bars, and make the number on the other side a negative, or make it the opposite. Okay, so let's look at this one. So first step, split it into two equations after the absolute value is isolated. Is the absolute value isolated in that one? Yes. So then it's ready to split into two. Can anyone tell me the first equation that I'm going to get when I split that into two? Yeah?
2x plus 3.
Anything else? So remember, we have to split it into equations. Is that an equation?
No.
No.
So how do you make an equation? Just set it equals to 0.
Yeah?
Would it be 2x plus 3 equals 5?
Right. So the first equation is the same as the original equation. So you take the original and you remove the bars. Okay? That's all you're doing, just removing the bars. What about my second equation? Yeah?
2x plus 3 equals -5.
Yeah. And now you just solve each equation. Even though you have two to solve, they're the same steps. -3 and divide by 2. So in this case, we get that x could be 1, or x could be -4. Those are our two answers.
So you're just flipping the -5?
Yeah, we're just making this number on the other side the opposite of what it was for the second equation. For the first equation, we keep it exactly the same. And you could check your answers, plug in 1. 2 times 1 is 2. 2 plus 3 is 5. And what's the absolute value of 5? Yours?
5.
5. Now plug in negative 4. 2 times negative 4 is how much? Negative 8. And what's negative 8 plus 3?
5.
Negative 5. And what's the absolute value of negative 5?
5.
5. Yeah. So both answers work perfect. How about if I had something like this one? Anybody notice anything about that? Yep.
It equals a negative.
Okay, it equals a negative. So what does that mean? Yeah,
Is there no solution?
that's no solution. You can split this into 2 problems and follow that method, but you'll never get an answer that works. Because how can you take the absolute value of something and get a negative number? That can never happen. So any solutions that you try to get using the method I show you will give you an answer of positive 10. You'll never get negative 10, but that's no solution. Now, what if I had this? Is that also no solution because the absolute value is equal to a negative? Why not? Yeah?
Because after you add 8 to both sides, the answer will become positive.
Right. You've got to isolate the absolute value. And once you do that, you're going to have 5 on the right, positive 5. So that problem would be okay. All right, so just a couple little things to watch out for. Okay, any questions on that? And the other application we're going to look at for linear equations is what's called a mixture problem. In a mixture problem, you are going to have to set up what's called a system of equations. You're going to have to set up 2. So the way that the mixture problem is going to work is I'm going to give you 2 solutions, and they're each going to have a certain concentration. Let's say maybe you've got, sometimes you buy like rubbing alcohol and it says like 90% rubbing alcohol or 80%. That's how much of the actual solution is rubbing alcohol, and then the rest they might mix with water. Right? So it's not pure, it's not 100%. It's like 80 or 90%. So I'm going to give you 2 solutions. Each one of them will have a certain percentage. Let's say you had that. You had an 80% rubbing alcohol and 90%. And I say, I want you to mix the 2 together to make me an 83% solution, which is doable. You got an 80 and you got a 90, but I need 83. And when you're done, I need 100 gallons of it. So how much of each would I have to mix together to make exactly 100 gallons and exactly 83% strength? All right? So that's why it requires 2 equations. One equation is for your total amount. In this case, it would be 100 gallons. And the second equation is for the concentration, 83% in this case. So you're going to need to know the concentration of solution number 1, which I think I said 80%. We'll write that as a decimal though. We got to use point. If we were doing that, it'd be 0.8. And then we need the concentration of solution 2. In my case, I think it was, I said 0.9, 90%. And then I need the final concentration, which I think ours was, I said 0.83, 83%. And the total amount of solution when I mixed it, I think I said it was 100 gallons. So they're going to tell you everything you need, and you just have to fill in those 2 equations. The things that are highlighted are what your variables are going to be. Amount 1 and amount 2 are the two variables you are not going to know. Everything else that's written there are going to be numbers. Those are the only 4 things that will be letters. All right, so let's see if we can solve them. And we'll come back to that after. Okay, so we have 2 different solutions. We've got a 10% and a 25%. So we can create any concentration in the middle. You can't get it higher than 25. Like if you mix these together, you can't get a 35% solution. That's not possible. Any question why that's not possible? Yep.
Yeah, why?
Because if you're starting with a solution that's already diluted down to 25% and you mix it with something weaker, it can't get stronger. The only way I could make it stronger is if I said, well, I've got a third solution that's 100% strength. Then I could mix that and make it stronger. But these are the only 2 solutions I've got. I got a 10% and a 25%. And I'm going to mix the 2 together. When I'm done, I want to create a 12% solution, which is doable. It's in the middle. And I want 15 liters of that solution. So they've already given us some letters in this problem, and I would reuse those letters to represent the amount of each solution that we need. So off to the side, I'm just going to say let A be the liters of solution number 1, and let B be the liters of solution 2. What do I know when I mix A and B together in terms of the final volume?
Say it again, please.
What do we know when we mix A and B together in terms of the volume? It has to equal 15 liters, yes. And how would you total up the amount of A and the amount of B mixed together? How would you find the total? You what? Yeah, you add. The amount of solution 1 plus the amount of solution 2 equals the total. So what's going to be our first equation? Substituting in our letters for amount 1 and amount 2. Yep.
A plus B equals
A plus B equals how much?
total.
We- 15. Yep. Okay, so there's your first equation. And if that's all you knew, there's a lot of answers to that. 14 plus 1 is 15. 10 plus 5. 9 plus 6. There's lots of combinations that add to 15. But only one of them will also give me something that's 12% concentration. Okay, so now we need concentration times amount. And we do that 3 times. Concentration, amount, concentration. Okay. What's the concentration of solution A as a decimal? 0.1. So you're going to fill that in right there. 0.1. And then the amount 1, well, we already know amount 1. We just did that up above. Amount 1 was A. What's the concentration of solution 2? What is it? 0.25. And then what's the amount of solution 2? B. Yep. And now, what's the final concentration? When I mix the 2 together, they want me to have a concentration of how much? 12% times the total, which we already know from up above is how much? 15. I'm just going to multiply, when you multiply 15 times 0.12, you get 1.8. I'm not going to rewrite the whole equation just for that step, but that's what it comes out to. So here's your two equations. Two equations, two variables. That's a system of equations. Does anybody remember one method you can use to solve a system? Yeah? You can definitely use elimination. I'm going to stay away from elimination on this one just because of all the decimals. Substitution would be a really good way to do this one. So with substitution, pick an equation and get one of the letters by itself. Which equation do you think is going to be easier to work with? Yeah, I would say the top one. There's no decimals in it. Which letter do you want to get by itself there? Doesn't matter. Nope, we can do A. So what would A equal if you got it by itself in the top one? Yeah?
15 minus B.
15 minus B. Now, what do you do with what's in that box, that 15 minus B? Yeah.
You plug it into the second equation.
Plug it into the second equation for what letter?
A.
Yes. I'm going to take that, and you're going to fill it in right there. Okay, let's do that and see what we get. So 0.1, make sure you put it in parentheses. A is 15 minus B. Now we've got an equation with only one letter in it. That's a linear equation, just like the one we solved before with distributive property. What's 0.1 times 15? 1.5. And 0.1 times negative b is just negative 0.1b. And that's it for the first step. Okay. What can I do on the left side now? Yeah, I've got some like terms. 0.25, take away 0.1. That's going to leave you with 0.15b. So I just combine the b's together. And what could I do with this 1.5 at the same time? Yep.
Subtract it.
Yeah, I could move that over to the other side. So combine the b's and then put the 1.5 on the right by subtracting it. And what's my last step to get b by itself? Yeah. Divide by 0.15. And if you want to think of that a little easier in your head, it's like dividing 30 by 15. Same thing. What's 30 divided by 15? 2. Yep. So we need 2 liters of solution A. How many liters would I need? I'm sorry, 2 liters of solution B. How many liters of solution A? 13, because it had to total 15. So you could just plug 2 in right there, and you could calculate A. 15 minus 2. And that's a pretty typical mixture problem. Come up with your equations, substitute, and then you you get both your answers. Any question on that? Okay, so last thing we're going to look at is a quadratic. When we're solving a quadratic, the difference is the highest exponent can be how much? Can be how much? Yeah, the highest exponent can be a 2. So these are all examples of quadratics. That's a quadratic. In that case, B is 0, C is 0, and A is 1. Bless you. This is a quadratic. This is a quadratic. They're all quadratics. You don't have to have every single term. You can have any of the combinations I just showed you. This is not a quadratic. No, because it has a square root. This is also not a quadratic. Can't divide by a variable. How about this one? Y equals 3x plus 2. Is that quadratic? That's linear. Nope. So those are not quadratics. The ones I didn't cross out are.
It has to have a square root.
What's that?
It has to have a square root. Or sorry,
If it has a square
Yeah,
root,
it has
it's
to be-
not a
it has to be
quadratic.
cube. Or not cube.
Square.
Square.
It has to have a power of 2. But just having a power of 2 doesn't always make it a quadratic. This is not a quadratic. You might say, well, yeah, it has a power of 2. No, the highest power has to be a 2. Highest power is a 5 in that one. All right, so one method we can use when we solve quadratics is to factor. Okay, so there's two main methods, factoring and quadratic formula. I usually try to factor it first. If I can't, then I go to quadratic formula. Okay, so if you don't remember, factoring is where you do your 2 sets of parentheses. And then you've got to figure out the first term here and here. What are 2 things you can multiply together to get 2x to the second power?
2x.
Perfect. 2x and 1x. Yep. And now, in the top, your middle sign is a positive. The sign on the constant is a negative. What does that mean you put down here? Right, that means you need a positive and a negative. In this case, it matters which one goes where. Worst thing that can happen is I have to switch them.
How do you know which one's right?
Well, I know that's right just because I practiced them a lot. But if you don't, you're going to check it, and then you'll know if you made a mistake when you check it. Yeah. And now I need 2 numbers here and here that multiply to give me 3. Yep. 3 and 1. I'm going to put them in a different order. I'm going to do a 1 and a 3. Because, watch what happens when we check it. We already know that when you multiply the first 2, you get 2x squared. We already know when you multiply negative 1 times 3, you get negative 3. This is what we don't know. Do we get 5x in the middle? What's 2x times 3?
6x.
6x. And what's negative 1 times x? And 6x, take away 1x? 5x. Perfect. If we got a negative 5x, I would have switched the positive and the negative. If we got a number that wasn't 5, then I would have tried switching the 1 and the 3. Okay, so the factoring, that's the hard part. Once we factor it, what do we set each of these factors equal to? set them equal to 0. At this point, now you're back at what we did in the first lesson, solving two linear equations. So from the first one, you get x equals 1/2. And what about the second one? How much?
-3.
Yep, perfect. X equals -3. Now that one was good because it factored. But does anybody remember the other method you can use if it doesn't factor? Quadratic what? Yeah. And do you remember what the quadratic formula is?
Plus or minus the square root of b squared minus 4ac over 2a.
Over 2a. Yep. So this method will work all of the time. You could even use this method on the last problem if you were having trouble with the factoring. But that is the quadratic formula. When you want to use the quadratic formula, it's important that you have your equation in standard form. That means it is already equal to 0. A is always the number in front of x squared. B is whatever is in front of the x. And C is the number at the end. Okay, so we'll finish up with doing one problem using quadratic formula. Okay, so let's try 2x squared plus 2x equals 1. Okay, first question. Is that equation in the right format? Not quite. What do we have to do to get it there? Yep.
So is that need to equal 0?
Yeah, we want to get it equal to 0 so we can clearly see the A, the B, and the C. Because some people might say C is 1 looking at the top one, and that's not right.
Now, if that was equal to 0, would C be 0? If it wasn't equal to 1, would C was equal to 0, would C be 0?
Yeah, yep. You can have a C value of 0. Yep. What's A in this case? 2. That number. What's B? B is also 2. That's just a coincidence. And what about C? -1. Okay. Let's fill that all into quadratic formula. And we get -b plus or minus the square root of b squared minus 4ac all over 2a. Now we're going to be subtracting a negative. What happens when you subtract a negative? Yeah, this is going to become addition because you're minusing the product of a negative here. So it's really just going to be addition. And what am I going to get under the square root? Yep, 12. Now, sometimes at that step you're done. But in this one, we can simplify 12. Yep.
When you do the multiplication, would you do the 4 minus 2 and then the 8, or 4 times 2 and then the 8 times the 1?
So you don't do anything with the division in this step. You're just going to multiply these together. Yeah. Yep. You just do all the multiplication and then 2 negatives become a positive. How can you break up the square root of 12? I want to think of it as something times something. But I need one of the numbers to be something I could take the square root of.
4 times 3.
Yes. This step doesn't always happen, but in this one it does. So 12 is 2 root 3. Okay. If you simplify square roots differently, that's fine. But you do have to, you've got to simplify. So that's -2 plus or minus 2 root 3 over 4. And once we simplify the square root of 12, what do we notice about all of those numbers? They're all divisible by 2. Okay, so we have to reduce that. This is something that doesn't always happen either. Just in this problem it did. What's 2 divided by 2? That becomes a 1. And then 2 divided by 2 again. What about 4 divided by 2? 2. So how would I write my final answer? Yep, perfect. That's the final answer. That's an exact answer, and it's reduced as much as you can. Yeah.
How'd you get 2 to the square root of 3?
2 times the square root of 3?
Yeah, 2 times the square root of 3.
Because 12 is 4 times 3. So you can break the square root of 12 up into 4 times 3. And anytime you have a product under a radical, you can split it into 2 radicals, just like that. And the square root of 4 is 2. And the square root of 3 is just 3. Oh, yeah, there's other ways to simplify that as well.
So you just go until you can't square root 1, then you put that
Right.
one outside, put the other one on the inside.
Yeah.
Thank you.
Okay, and that's solving quadratics. Okay, so homework tonight, it is on 2 different pages. The first page, 35 to 39, that's a break-even point problem. It's all the same question. And then page 96, that's on solving the equations.